All right, with that, it is time to begin the observer pattern chapter. So everything's looking good. Let's move forward. Observer. You can't throw a rock at a computer without hitting an application built using the model view controller architecture. And underlying that is the observer pattern. Observer is so pervasive that Java put it in its core library, java.util.observer, and C# baked it right into the language, the event keyword. And then a sidebar, like so many things in software, MVC was invented by small talkers in the 70s. Lispers probably claim they came up with it in the 60s, but didn't bother writing it down. Observer is one of the most widely used and widely known of the original Gang of Four patterns, but the game development world can be strangely cloistered at times. So maybe this is all news to you. In case you haven't left the Abbey in a while, let me walk you through a motivating example. It is true, the model view controller is extremely pervasive in the web development world, especially with like Node.js backend and using Express. Achievement unlocked. Say we're adding an achievement system to our game. It will feature dozens of different badges players can form for completing specific milestones like kill 100 monkey demons, fall off a bridge, or complete a level wielding only a dead weasel. He actually drew out a little like Steam notification, Weasel achievement, or achievement Weasel Wielder. I swear I had no double meaning in mind when I drew this. I hadn't even thought of double meaning when I read it. Okay, this is tricky to implement cleanly since we have such a wide range of achievements that are unlocked by all sorts of different behaviors. If we aren't careful, tendrils of our achievement system will twine their way through every dark corner of our code base. Sure, fall off a bridge is somehow tied to the physics engine, but do we really want to see a call to unlock fall off bridge right in the middle of the linear algebra in our collision resolution algorithm? What we'd like, as always, is to have all the code concerned with one facet of the game nicely lumped in one place. The challenge is that achievements are triggered by a bunch of different aspects of gameplay. How can that work without coupling the achievement code to all of them? This is a rhetorical question. No self-respecting physics programmer would ever let us sully their beautiful mathematics with something as pedestrian as gameplay. That's what the observer pattern is for. It lets one piece of code announce that something interesting happened without actually caring who receives the notification. For example, we've got some physics code that handles gravity and tracks which bodies are relaxing on nice flat surfaces and which are plummeting toward sure demise. To implement the fall off a bridge badge, we could just jam the achievement code right in there, but that's a mess. Instead, we can just do okay, so we have void physics, and again, this is, I believe, C++, but without most of the C++ special features. Void physics, okay, so create physics, update entity, method off of physics, class, it's going to return nothing. Update entity takes in a reference to an entity. We create was on surface a boolean. Let's actually write this out. So in game design patterns, go into our P5 info runner. We'll open up code here. here's this code example, and then in my playground, I'm going to create a new file called observer.js. All right, so let's actually take a look through this and sort of convert this code into sort of like JavaScript to begin with. So we have this void physics update entity. That sounds a lot like this is going to be a method on a class. So we have a class physics, and then we're going to have this method update entity that's going to take in an entity. Now we're going to have was on surface. That's a variable. It's a boolean. A variable that can be a boolean equals entity is on surface. So it's going to ask like, hey, are we on a surface? If our const was on surface entity dot is on surface. Okay, so is it now on the surface again? Then we're gonna okay, so then we're just going to have the entity accelerate the gravity. So entity dot accelerate. We're gonna pass it in like, so we probably have a gravity. So in a constructor maybe we'll have something like this dot gravity equals like, I don't know, this probably has to be a vector of some kind. So we might create a vector of negative, well actually gravity is only affects y, so it'd be like 0 and 1. This means that into accelerate we're going to pass this dot gravity. Then we're going to have the entity update its position. And if was on surface, okay, so if this is true, so if we were on the surface, if the entity was on the surface, and the entity is no longer on the surface, if was on surface, and now the opposite, so we're no longer on the surface, entity dot is on surface, then we have this entire notify thing. So notify entity event start fall. Now this notify, like, we don't know where it comes from necessarily. So it might be a global. You're going to notify the entity, and then this looks like a it's probably like an enum or some kind of just global. This is what happens. So you can just do event start fall, and that way the entity can register for when this happens with our notification system. And then register for, okay, when event start fall happens, I will check to see if I've done this before, and then I will reward the player if this is the first time ever. All it does is say, I don't know if anyone cares, but this thing just fell. Do with that as you will. So it could be the entity, it could be the player, it could be an AI. The physics engine does have to decide what notifications to send, so it isn't entirely decoupled, but in architecture we're most often trying to make systems better, not perfect. The achievement system registers itself, so that whenever the physics code sends a notification, the achievement system receives it. It can then check to see if the falling body is our less than graceful hero, and if his perch prior to this new unpleasant encounter with classical mechanics was a bridge. If so, it unlocks the proper achievement with his associated fireworks and fanfare, and does all of this with no involvement from the physics code, except this notification that happened that set that all up. In fact, we can change the set of achievements or tear out the entire achievement system without touching a line of the physics engine. It will still send out its notifications, oblivious to the fact that nothing is receiving them anymore. This is something that actually I really like in just normal web development mode, specifically Vue.js. There's that ability to like send bubble events like up to the top. And I really like this pattern in programming. Of course, if we permanently remove achievements and nothing else ever listens to the physics engine's notifications, we may as well remove the notification code too. But during the game's evolution, it's nice to have this flexibility. And what if you start listening to it again? I mean, then you want it there. I mean, there's a lot of what ifs when you're trying to predict change. That's why predictions are hard. How it works. If you don't already know how to implement the pattern, you could probably guess from the previous description. But to keep things easy on you, I'll walk through it quickly. The observer. We'll start with the nosy class that wants to know when another object does something interesting. These inquisitive objects are defined by this interface. Okay, so we have a class observer, and then it's declaring two public functions. Oh, okay, so this is just a normal interface. Interfaces look very different in C++. I keep on expecting to see the keyword interface. All right, so observer public, so I'm going to have a function observer and a function onNotify. This onNotify returns nothing. This observer, I don't know what it... Oh, it's a capital O. Oh no, this is the constructor. Okay, right. I keep on forgetting the constructor is just the same name of the class. So the constructor, it has a constructor and it has an onNotify. So there's not really a clean, easy way to do interfaces in JavaScript without diving into TypeScript. But if I do this, and I guess this won't really be the interface, it'll just be the full thing. So we have the observer, we have a constructor that doesn't really do anything. And then we have this onNotify. And so it's going to take in an entity. And it's going to take in an event. And so my guess is it's going to have an object where we basically register the event and the entities that want to be known of this event. And then when notify happens, it'll look through all of the entities and all the events and then notify each entity that registered for that event. The parameters to onNotify are up to you. That's why this is the observer pattern and not the observer ready-made code that you can paste into your game. Typical parameters are the object that sent the notification and a generic data parameter you stuff other details into. If you're coding in a language with generics or templates, you probably use them here, but it's also fine to tailor them to your specific use case. Here, I'm just hard coding it to take a game entity and an enum that describes what happened. Any concrete class that implements this becomes an observer. In our example, that's the achievement system. So we'd have something like so. Okay, so we have our achievements class, which implements the observer class. Oh, interesting. So public, virtual, okay. So we have onNotify, so it has to now implement onNotify. and it will just okay, switch event off the event that comes in. Case event entity fell. If hero is hero and hero is on bridge, then unlock achievement fell for bridge. Make that. So he's using a switch statement or just a bunch of if else statements. Handle other events. Right, so you could have just a whole bunch of events. Then we have this unlock. That's what it's calling. And then a Boolean hero is on bridge. Well, that's interesting. He has just a variable, heroes on bridge. That's a private variable. So I'm guessing there's some kind of like, why would achievements care about that? I don't know. I don't like that necessarily. But if we were to implement this class achievements, and this is going to extend observer. So this may so we're gonna have to overwrite on notify, so it actually does something that we care about. We may or may not have a constructor with this one, but okay. So on notify, we know that it takes an entity and event, and here's where we like do something with this entity. And it looks like they're suggesting a switch statement. I go back and forth on liking switch statements, especially after learning match statements, which are very, very similar to switch statements. It makes me kind of want to use them again, except I want the protection of match, so that fall through can't happen. But all right, so if we switch off of the event, I think that's the same. I think it's pretty much the same exact syntax. So switch off of event. Then we have the various cases. So case, event, entity fell. Then in here, then if entity is hero, okay, so we want to see like, okay, are you the hero? So we ask the entity. So if entity, are you the hero? And here they have the like a private variable here. So they have something like now there's no private in just normal JavaScript at this time yet. It's being worked on. This would be essentially this dot hero is on bridge. So and this dot hero is on the bridge. So if that is true, then there's some kind of unlock function. And we're going to call that and pass it lots of global sort of constants here. Okay, so fell off the bridge. Of course, in cases, we can't forget to break that. So that's the end of on notify. And then they have this other function unlock, which takes in, it looks like just the achievement. And then it basically just does do the unlock, and that's pretty much it. So that's like what the achievement who is an observer would be like. The subject. The notification method is invoked by the object being observed. In Gang of Four parlance, that object is called the subject. It has two jobs. First, It holds the list of observers that are waiting oh so patiently for a missive from it. Okay, so class subject, private observer, that has the observers, and then, it has like int number of observers, but if this is an array, then we can just do array.length in JavaScript. So it sounds like we might not want to like separately store this as an int to do our own ref counting. In real code, you would use a dynamically sized collection instead of a dumb array. I'm sticking with the basics here for people coming from other languages who don't know C++'s standard library. Yes, so JavaScript arrays are dynamically sized. So if I have a class subject, then we have a constructor, this dot observers is essentially just going to be a normal standard array, which means we don't need to implement int num observers because we don't need to, like, we could just get observers.length to figure out what size it is. The important bit is that the subject exposes a public API for modifying that list. So add observer and remove observer. So add observer, looks like it takes an observer, and all that's going to do is this dot observer dot push the observer, and this is observers. And it looks like it's going to be the exact same thing for remove observer, except this one would require us to like figure out where it is in there. So remove observer. I see that he didn't actually implement that, so I guess I won't here. So find and remove observer from array. That allows outside code to control who receives notifications. The subject communicates with the observers, but it isn't coupled to them. In our example, no line of physics code will mention achievements, yet it can still talk to the achievement system. That's the clever part about this pattern. It's also important that the subject has a list of observers instead of a single one. It makes sure that observers aren't implicitly coupled to each other. For example, say the audio engine also observes the fall event so that it can play an appropriate sound. If the subject only supported one observer, when the audio engine registered itself, it would unregister the achievements system. Oh, right, because like it's the only thing that's allowed. So, you know, the entire point system, everything else, that would be gone. That means those two systems would interfere with each other, and in a particularly nasty way, since the second would disable the first. Supporting a list of observers ensures that each observer is treated independently from the others. As far as they know, each is the only thing in the world with eyes on the subject. The other job of the subject is sending notifications. Okay, so we have our class subject, so same class subject here. We have our notify. And so this, so this is now going to notify all of our observers. So we now have a notify method here. This is going to take a reference to an entity. Everything that's an object in JavaScript is already a reference, so that we have that there. And then the event that that is being passed in. And so we saw earlier that notify is being called here. So that means that our physics engine is going to have an instance of subject. So we have this notify. It takes in an entity and event. Okay, so we're going to loop through all of the number of observers. So this dot observe. Oh, right. So we're going to loop through all the observers. And so in JavaScript, I would probably use an array method here. So this dot observers dot for each, and that is going to give us a reference to an observer. And here we're going to say, okay, call. Notice that this is an observer that has an onNotify. So we're just going to say observer dot onNotify. We're going to pass in the entity and the event. So that way, if there's multiple, well, if a bunch of things have asked, like, hey, I want to get notifications when something happens, this does that for them. Note that this code assumes observers don't modify the list in their onNotify methods. A more robust implementation would either prevent or gracefully handle concurrent modification like that. So the idea, I think what he's talking about is onNotify. So where is... yeah, so the observer onNotify, so maybe the observer doesn't want to be here anymore, or like wants to change around. I don't know, I think that would just work in JavaScript because, you know, the entire everything is a reference. It could even change its own type. But we might run into problems with that with Rust, but maybe not with our simplified system. Observable physics. Now, we just need to hook all of this into the physics engine so that it can send notifications and the achievement system can wire itself up to receive them. We'll stay close to the original design pattern's recipe and inherit subject. Okay, so back to, here's our physics engine, but now we're going to extend subject. So extends subject. Public. Okay, so then it's going to have this update entity, which we already have here, takes an entity. This lets us make notify in subject protected. So notify is now protected. What protected means in object-oriented is that only children are allowed to call it. It can't be called as a singleton, and it can't be called by itself. I believe that's what it is. So notify can now only be called by, for example, physics that extends subject. That was the way the derived physics engine class can call it to send notifications, but code outside of it cannot. Meanwhile, add observer and remove observer are public, so anything that can get to the physics system can observe it. Yeah, these ones. In real code, I would avoid using inheritance here. Instead, I'd make physics have an instance of subject. Instead of observing the physics engine itself, the subject would be a separate falling event object. Observers could register themselves using something like physics.entity_val add observer this. I guess that would be the physics instance itself. To me, this is the difference between observer systems and event systems. With the former, you observe the thing that did something interesting. With the latter, you observe an object that represents the interesting thing that happened. Oh, interesting. So instead of subject, like we could instantiate subject as all the different events. So I think what he's suggesting here is somewhere in our code we can have something like entity fell equals new subject. Now that will have like all these observers, and we can add an observer. So now entity fell, we can pass that around to everything else when we create it. And then it can say, hey, I want to add myself as an observer of this this event object. Now, when the physics engine does something noteworthy, it calls notify, like in the motivating example before, that walks the observer wet list and gives them all the heads up. So we have observers, it goes through every single one, and it doesn't matter what type of observer it is, it just sends it out. Pretty simple, right? There's one class that maintains a list of pointers to instances of some interface. It's hard to believe that something so straightforward is the communication background of countless programs and app frameworks. But the observer pattern isn't without its detractors. When I've asked other game programmers what they think about this pattern, they bring up a few complaints. Let's see what we can do to address them, if anything. So I'm going to save this. I'm not implementing this other one because it is a sidebar and it's not actually part of the pattern for real. But something I realized, if we go into our README, can you not find the README in here? Oh, I didn't have a README on this one. I have a README like up above. Let's add a README. Okay, so this is going to be JavaScript infinite runner. All right, so observer pattern, we're going to want to add in. And here's like based upon that example of falling off a bridge, I'm thinking the example that we can add in for ours is going to be the score. So like refactor scoring to use observer pattern. It's too slow. I hear this a lot, often from programmers who don't actually know the details of the pattern. They have a default assumption that anything that smells like a design pattern must involve piles of classes and indirection and other creative ways of squandering CPU cycles. The observer pattern gets a particularly bad rap here because it's been known to hang around with some shady characters named events, messages, and even data binding. Some of those systems can be slow, often deliberately and for a good reason. They involve things like queuing or doing dynamic allocation for each notification. This is why I think documenting patterns is important. When we get fuzzy about terminology, we lose the ability to communicate clearly and succinctly. You say observer, and someone hears events or messaging because either no one bothered to write down the difference or they didn't happen to read about it. That's what I'm trying to do with this book, to cover my bases. I've got a chapter on events and messages queue, too. Event queue. But now that you've seen how the pattern is actually implemented, you know that isn't the case. Sending a notification is simply walking a list and calling some virtual methods. Granted, it's a bit slower than statically dispatched call, but that cost is negligible in all but the most performance critical code. I find this pattern best fits outside of hot code paths anyways, so you can usually afford the dynamic dispatch. Aside from that, there's virtually no overhead. We aren't allocating objects for messages. There's no queuing. It's just an indirection over a synchronous method call. Another common complaint, it's too fast, which is hilarious because the previous one was it's too slow. In fact, you have to be careful because the observer pattern is synchronous. The subject invokes its observers directly, which means it doesn't resume its own work until all of the observers have returned from their notification methods. A slow observer can block a subject. This sounds scary, but in practice, it's not the end of the world. It's just something you have to be aware of. UI programmers, who've been doing event-based programming like this for ages, have a time-worn motto for this: stay off the UI thread. If you're responding to an event synchronously, you need to finish and return control as quickly as possible so that the UI doesn't lock up. When you have slow work to do, push it onto another thread or a work queue. You have to be careful mixing observers with threading and explicit locks, though. If an observer tries to grab a lock that the subject has, you can deadlock the game. In a highly threaded engine, you may be better off with asynchronous communication using an event queue. In JavaScript, I don't think, especially in our game, we're not going to have a problem of like slowing down the game. I don't think from this. Maybe in the Rust side, we might end up having a problem, but we haven't played with threads yet. So if necessary, we can go into a threading system and potentially implementing an event queue for it. But of course, the event queue looks like it's going to be a future chapter. It does too much dynamic allocation. Whole tribes of programmer clan, including many game developers, have moved on to garbage-collected languages, and dynamic allocation isn't the boogeyman that it used to be. But for performance-critical software like games, memory allocation still matters, even in managed languages. Dynamic allocation takes time, as does reclaiming memory, even if it happens automatically. So, fun fact about JavaScript. Garbage collection in JavaScript happens every 300 milliseconds or so. Starting since node 10, so whatever Chrome engine is in node 10, so that's also in the Chrome browser, it's been offloaded into a thread. So it doesn't block the main thread when it does garbage collection, which is really good because some of these objects can be huge, which can cause slowdowns. So JavaScript is a little bit better about this. Rust is even better because there's no garbage collection, but at the end of every single block, it just deletes all, it just frees up the memory automatically. So there's no garbage collection, but there's also no manual memory management either, which is super nice. Many game developers are less worried about allocation and more worried about fragmentation. When your game needs to run continuously for days without crashing in order to get certified, an increasingly fragmented heap can prevent you from shipping. The Object Full chapter goes into more detail about this and a common technique for avoiding it. In the example code before, I used a fixed array because I'm trying to keep things dead simple. In real implementations, the observer list is almost always a dynamically allocated collection that grows and shrinks as observers are added and removed. That memory churn spooks some people. I'm guessing what he means by a collection is like a dictionary or a hash map or some kind of object in JavaScript. Of course, the first thing to notice is that it only allocates memory when observers are being wired up. Sending a notification requires no memory allocation whatsoever. It's just a method call. If you hook up your observers at the start of the game and don't mess with them much, the amount of allocation is minimal. If it's still a problem though, I'll walk through a way to implement adding and removing observers without any dynamic allocation at all. Okay, linked observers. In the code we've seen so far, subject owns a list of pointers to each observer. Watching it. The observer class itself has no reference to this list. It's just a purely virtual interface. Interfaces are preferred over concrete stateful classes. That's generally a good thing. But if we are willing to put a bit of state in the observer, we can solve our allocation problem by threading the subject's list through the observers themselves. Instead of the subject having a separate collection of pointers, the observer objects become nodes in a linked list. Ooh, so it looks like we're going to implement a linked list here. So here is our observer sort of class. It's kind of an interface because there's no implementation in it, but it looks like we're about to change that. So we're going to have our subject, and it's going to have the heads that goes to like, oh no, that says that I am the head. And then we probably have a next to point to it. To implement this, first we'll get rid of the array and subject and replace it with a pointer to the head of the list of observers. So in subject here, instead of this observers, we're now going to have just, I guess, a head, and it's null. This dot head equals null. Now in methods, okay, so this isn't really a method. This is just registering a private variable on this. So we've got that as kind of. Then we'll extend observer with a pointer to the next observer in the list. So here we have our class observer. Friend class subject. I've never even heard of friend class. It's cool that observer has a friend here, but I think we'll just extend. I think that's what that means. So in public, so we're going to have the constructor. The constructor here, we're going to set next. So this dot next equals null. And other stuff, so private, so yeah, we're just registering next. We're also making subject a friend class here. The subject owns the API for adding and removing observers, but the list it will be managing is now inside the observer class itself. The simplest way to give it the ability to poke at that list is by making it a friend. Registering a new observer is just wiring it into the list. We'll take the easy option and insert it at the front. So in subject, when we add observer, we take in the observer. Observer next becomes, okay, whatever's the head becomes the next. So it looks like we're going to want to register like this dot next set equal to null. Oh no, we don't have a next here at all. So subject just has the head. And it looks like so instead of this, we're going to say, for this observer that's coming in, observer.next equals the head. So you're at the beginning. This dot head. And then head. Oh, okay. So whatever was in head, you're now in this observer's next. And now we're going to say this dot head equals the observer. That's what's happening here. We're saying, okay, observer, you're new head, but before that, before we lose our current head, observer, keep track of this. The other option is to add it to the end of the linked list. Doing that adds a bit more complexity. Subject has to either walk the list to find the end or keep a separate tail pointer that always points to the last node. Adding it to the front of the list is simpler, but does have one side effect. When we walk the list to send a notification to every observer, the most recently registered observer gets notified first. So if you registered observers A, B, and C in that order, they will receive notifications in CBA order. In theory, this doesn't matter one way or the other. It's a tenet of good observer discipline that two observers observing the same subject should have no ordering dependencies relative to each other. If the ordering does matter, it means those two observers have some subtle coupling that could end up biting you. Let's get removal working. Okay, so in our remove observer, so it takes in our observer. We're no longer having this array to remove from. Now we need to check to see, okay, if our head is the observer. So if this dot head, if that is an instance of this observer, then we want to set head equals observer next. Right, so we're going to delete this observer. So the current head goes away, and whatever is on its next becomes the new head again. So this dot head equals observer dot next. And it wants us to return after this. So that way we're just done. We don't have to have an else at this point. I've been forgetting this closing parentheses recently. Just today, I guess. Observer current equals head. Okay, so we're going to set, so now we're going to do our, essentially a loop through. So we're going to say const our current equals this dot head. So we're going to start keeping track of this. My guess is, yeah, this needs to be a let, because we are going to override current with where it is somewhere else. We're going to now while loop, so while current does not equal to null. So while we're looping through all of these, if current next is the observer, right? So we're basically saying we want to now loop through all of the rest of the ones. This is interesting as like current next. I could also set current to this head dot next as well, and then do the loop that way. However, let's just try this. If current dot next, if that is equal to our observer, so it's an instance of our observer, then we want to remove it from here. Oh, that's the reason why we're keeping the next here. So now we can just say, hey, current dot next, set you equal to the observer dot next, which will just remove it. It's gone. And observer next, set that equal to null. So observer dot next equals to null. So that essentially deletes its reference to the next one. So it's now completely removed from this linked list. We are going to return out of here, not just return from, like, not just break out of the loop, but fully return from the function. And we can't forget that while we're in this loop, we need to reset current. So we haven't found the current observer yet. So current equals observer, I guess the next one. So current dot next. That will be our remove observer. So walk through a linked list, check to see if which one is in there, and kind of just sort of remove it and shift everything over if we find it. Removing a node from a linked list usually requires a bit of ugly special case handling for removing the very first node, like you see here. There's a more elegant solution using a pointer to a pointer. I didn't do that here because it confuses at least half the people I show it to. It's a worthwhile exercise for you to do, though. It helps you really think in terms of pointers. We're not going to do that here. Also, like, pointers are, like, can be kind of dangerous. Because we have a singly linked list, we have to walk it and find the observer we're removing. We'd have to do the same thing if we were using a regular array for that matter. If we use a doubly linked list, where each observer has a point to both the observer after it and before it, we can remove an observer in constant time. If this were real code, I'd do that. The only thing left to do is send a notification. That's as simple as walking the list. Okay, so in notify, it's going to be similar, but there's no array methods on linked lists, unfortunately. So instead of this entire for each here, we're going to, let's see, observer equals the head. Oh, interesting. Okay, so so he's going to do another while loop. That's because we don't know how many there are. We could potentially keep a count of it, or we could just do what he does. And we'll do let observer equals to this dot head. Then while the observer is not equal to null. In JavaScript, I could just do while observer. While observer variable is a thing, then we can do observer dot on notify, pass it in this entity and event, and then we're going to take our observer and set it equal to observer dot next. Here we walk the entire list and notify every single observer in it. This ensures that all of the observers get equal priority and are independent of each other. We could tweak this such that when an observer is notified, it can return a flag indicating whether the subject should keep walking the list or stop. If you do that, you're pretty close to having the chain of responsibility pattern. Not too bad, right? A subject can have as many observers as it wants, without a single whiff of dynamic memory. Registering and unregistering registering is as fast as it was with a simple array. We have sacrificed one small feature though. Since we are using the observer object itself as a list node, that implies it can only be part of one subject's observer list. In other words, an observer can only observe a single subject at a time. In a more traditional implementation where each subject has its own independent list, an observer can be in more than one of them simultaneously. You may be able to live with that limitation. I find it more common for a subject to have multiple observers than vice versa. If it is a problem for you, there is another more complex solution that you can use that still doesn't require dynamic allocation. It's too long to cram into this chapter, but I'll sketch it out and let you fill in the blanks. A pool of list nodes. Like before, each subject will have a linked list of observers. However, those list nodes won't be the observer objects themselves. Instead, they'll be separate little list node objects that contain a pointer to the observer and then a pointer to the next node in the list. So it looks like, okay, so we have the subject. So it would be like this subject, an instance of the subject has a head that points to a node as next and observer. And so the observer points to the observer. And so then I guess that allows us to have a really long linked list, but with like one observer could be in it multiple times. Since multiple nodes can all point to the same observer, that means an observer can be in more than one subject's list at the same time. We're back to being able to observe multiple subjects simultaneously. Linked lists come in two flavors. In the one you learned in school, you have a node object that contains the data. In our previous linked observer example, that was flipped around. The data, in this case, the observer, contained the node, i.e. the next pointer. The latter style is called an intrusive linked list because using an object in a list intrudes into the definition of that object itself. That makes intrusive lists less flexible, but as we've seen, also more efficient. They're popular in places like the Linux kernel, where that trade-off makes sense. So fun fact, I did not go through computer science classes in university. I did more of a computer information technology, which did mean that I learned like some things, but not necessarily programming. So not linked lists. That came a lot later when I was teaching, and I learned all this so that I could teach it. The way you avoid dynamic allocation is simple. Since all of those nodes are the same size and type, you pre-allocate an object pool. an object pool of them. Okay, it looks like object pool is going to be another pattern we go through. That gives you a fixed size pile of list nodes to work with, and you can use and reuse them as you need without having to hit an actual memory allocator. Remaining problems. I think we banished the 3 boogeymen used to scare people off this pattern. As we've seen, it's simple, fast, and can be made to play nice with memory management. But does that mean you should use observers all the time? Now that's a different question. Like all design patterns, the observer pattern isn't a cure-all. Even when implemented correctly and efficiently, it may not be the right solution. The design pattern gets a bad rap because people apply good patterns to the wrong problem and end up making things worse. 2 challenges remain, one technical and one at something more like the maintainability level. We'll do the technical one first because those are always the easiest. Destroying subjects and observers. The sample code we walked through is solid, but it sidesteps an important issue. What happens when you delete a subject or an observer? If you carelessly call delete on some observer, a subject may still have a pointer to it. That's now a dangling pointer into deallocated memory. When that subject tries to send a notification, well, let's just say you're not going to have a very good time. Rust, not going to have a problem with that because it's going to take care of making sure that the lifetimes match up. So if something gets deleted or has the possibility of getting deleted, we won't need to worry about it. Not to point fingers, but I'll note that design patterns doesn't mention this issue at all. JavaScript, so if we do the linked list like this, I could see it being a problem in JavaScript too, but it won't be a security problem. It would just like throw an error essentially. Destroying the subject is easier since in most implementations, the observer doesn't have any references to it. But even then, sending the subject's bits to the memory manager's recycle bin may cause some problems. Those observers may still be expecting to receive notifications in the future, and they don't know that will never happen now. They aren't observers at all. Really, they just think that they are. You can deal with this in a couple of different ways. The simplest is to do what I did and just punt on it. It's an observer's job to unregister itself from any subjects when it gets deleted. More often than not, the observer does know which subjects it's observing, so it's usually just a matter of adding a remove observer call to its destructor. As is often the case, the hard part isn't doing it, it's remembering to do it. So potentially adding in this is going to be more important for Rust, adding in I guess like a trait for the destructuring might be really important here, but also it should just warn us if we're going to use something that potentially is removed before we use it. If you don't want to leave observers hanging when a subject gives up the ghost, that's easy to fix. Just have the subject send one final dying breath notification right before it gets destroyed. That way, any observer can receive that and take whatever action it thinks appropriate. Warn, send flowers, compose, elegy, etc. People, even those of us who spent enough time in a company of machines to have some of their precise nature rub off on us, are reliably terrible at being reliable. That's why we invented computers. They don't make the mistakes we so often do. A safer answer is to make observers automatically unregister themselves from every subject when they get destroyed. If you implement the logic for that once in your base observer class, everyone using it doesn't have to remember to do it themselves. This does add some complexity though. It means each observer will need a list of the subject it's observing. You end up with pointers going in both directions. Don't worry, I've got a GC. All you cool kids with your hip modern languages with garbage collectors are feeling pretty smug right now, thinking you don't have to worry about this because you never explicitly delete anything. Think again. Imagine this. You got some UI screen that shows a bunch of stats about the player's character, like their health stuff. When the player brings up the screen, you instantiate a new object for it. When they close it, you just forget about the object and let the garbage collector clean it up. Every time the characters take a punch to the face, or elsewhere I suppose, it sends a notification. The UI screen observes that and updates the little health bar. Great! Now, what happens when the player dismisses the screen, but you don't unregister the observer? The UI isn't visible anymore, but it won't get garbage collected since the character's observer list still has a reference to it. Every time the screen is loaded, we add a new instance of it to the increasingly long list. The entire time the player is playing the game, running around and getting in fights, the character is sending notifications that get received by all of those screens. They aren't on screen, but they receive notifications and waste CPU cycles updating invisible UI elements. If they do other things like play sounds, you'll get noticeably wrong behavior, like multiple sounds being played at the same time. This is such a common issue in notification systems that it has a name, the lapsed listener problem. Since subjects retain references to their listeners, you can end up with zombie UI objects lingering in memory. The lesson here is to be disciplined about unregistration. An even surer sign of its significance, it has a Wikipedia article. So the big thing here is that in JavaScript, which is a garbage collected language, if there is any reference to an object, it will not be garbage collected. So for example, here in subject, we have references to these objects. So if we delete it somewhere else, there's still a reference to it here. And deleting, like, you don't delete an object by saying like, hey, go like scrub the memory and like put zeros over its place. Instead, you just remove all references to it, and then a garbage collector says like, ooh, you're like, you know, an isolated object. Time to clean you up. We need to remove. We need to remember to remove this observer when it gets removed from everything else as well. But something else that I sort of like realized here is we could definitely have a UI. So we have scoring to use an observer pattern. It's really going to be just like the UI to use the observer pattern. So I guess what that means is like a class for UI, and then the UI listens for events to update like score, for example. What's going on? The other deeper issue with the observer pattern is a direct consequence of its intended purpose. We use it because it helps us loosen the coupling between two pieces of code. It lets a subject indirectly communicate with some observer without being statically bound to it. This is a real win when you're trying to reason about the subject's behavior, and any hangers-on would be an annoying distraction. If you're poking at the physics engine, you really don't want your editor or your mind cluttered up with a bunch of stuff about achievements. On the other hand, if your program isn't working and the bug spans some chain of observers, reasoning about that communication flow is much more difficult. With an explicit coupling, it's as easy as looking up the method being called. This is child's play for your average IDE since coupling is static. But if that coupling happens through an observer list, the only way to tell who will get notified is by seeing which observers happen to be in that list at runtime. Instead of being able to statically reason about the communication structure of the program, you have to reason about its imperative dynamic behavior. My guideline for how to cope with this is pretty simple. If you often need to think about both sides of some communication in order to understand a part of the program, don't use the observer pattern to express that linkage. Prefer something more explicit. When you're hacking on some big program, you need to have lumps of it that you work on all together. We have lots of terminology for this, like separation of concerns, and coherence and cohesion, and modularity. But it boils down to this stuff goes together and doesn't go with this other stuff. The observer pattern is a great way to let those mostly unrelated lumps talk to each other without them merging into one big lump. It's less useful within a single lump of code dedicated to one feature or aspect. That's why it fits our example well. Achievements and physics are almost entirely unrelated domains, likely implemented by different people, who want the bare minimum of communication between them so that working on either one doesn't require much knowledge of the other. Observers today. Design patterns came out in 1994. Back then, object-oriented programming was the hot paradigm. Every programmer on Earth wanted to learn OOP in 30 days. Middle managers paid them based on the number of classes they created. Engineers judged their mettle by the depth of their inheritance hierarchies. That same year, Ace of Base had not one but 3 hit singles. So that may tell you something about our taste and discernment back then. The observer pattern got popular during the zeitgeist, so it's no surprise that it's class heavy. But mainstream coders are now more comfortable with functional programming. Having to implement an entire interface just to receive a notification doesn't fit today's aesthetic. It feels heavyweight and rigid. It is heavyweight and rigid. For example, you can't have a single class that uses different notification methods for different subjects. This is why the subject usually passes itself to the observer, since an observer only has a single onNotify method. If it's observing multiple subjects, it needs to be able to tell which one called it. A more modern approach is for an observer to be only a reference to a method or function. In languages with first-class functions, and especially ones with closures, this is a much more common way to do observers. These days, practically every language has closures. C++ overcame the challenge of closures in a language without garbage collection, and even Java finally got its act together and introduced them in JDK 8. For example, C# has events baked into the language. With those, the observer you register is a delegate, which is that language's term for a reference to a method. In JavaScript's event system, observers can be objects supporting a special event listener protocol, but they can also just be functions. The latter is almost always what people use. If I were designing an observer system today, I make it function-based instead of class-based. Even in C++, I would tend towards a system that lets you register member function pointers as observers instead of instances of some observer interface. Here's an interesting blog post on one way to implement this in C++. It goes to molecular musings. Interesting. I might take a look at that later. I'll see. Let's put a link to that in chat. Observers tomorrow. Event systems and other observer-like patterns are incredibly common these days. They're a well-worn path. But if you write a few large apps using them, you start to notice something. A lot of the code in your observers ends up looking the same. It's usually something like, get notified that some state has changed. Imperatively modify some chunk of UI to reflect the new state. It's all, oh, the hero's health is 7 now? Let me set the width of the health bar to 70 pixels. After a while, that gets pretty tedious. Computer science academics and software engineers have been trying to eliminate that tedium for a long time. Their attempts have gone under a number of different names: data flow programming, functional reactive programming, etc. While there have been some successes, usually in limited domains like audio processing or chip design, the holy grail still hasn't been found. In the meantime, a less ambitious approach has started gaining traction. Many recent application frameworks now use data binding. Unlike more radical models, data binding doesn't try to entirely eliminate imperative code and doesn't try to architect your entire application around a giant declarative data flow graph. What it does do is automate the busy work where you're tweaking a UI element or calculated property to reflect a change to some value. Like other declarative systems, data binding is probably a bit too slow and complex to fit inside the core of a game engine. But I would be surprised if I didn't see it start making inroads into less critical areas of the game like UI. In the meantime, the good old observer pattern will still be here waiting for us. Sure, it's not as exciting as some hot techniques that manages to cram both functional and reactive in its name, but it's dead simple and it works. To me, those are often the two most important criteria for a solution. And that is the chapter on observer pattern. So next time I'll be implementing the observer pattern into our JavaScript infinite runner game. And this is sort of like the idea of what I'm thinking of. Refactor UI to use the observer pattern. So what does that mean? It means we have a class for the UI. So this, like in Rust, that would be like a struct for the UI as well. But we need a class for the UI that's going to draw the score to the screen. And I guess it'll also draw the frames per second to the screen too. So do the class for the UI, not that start. Then we need this UI to listen to events for the updated score, which means that we need to have this entire notification system set up for us. If we want to use the functional method for it, let's go back and take a look at what that means. So we're going to have this subject. I'm not sure how I feel about like subject as the name of the class here, but it's going to be, okay, the entity eval. I wonder if this would be best as like specifically like event. Like we have a new event. Okay, the entity eval is a new event. Now, what that means is this entity eval will have an observer, have the ability to add observers to it, remove observers from it, and of course, notify all the observers who are caring about it. This might be the best way. And then when we register a new, I guess when we register achievement system, instead of extending observer, it sounds like this would take in the different events that it's going to care about. So I guess, what do we call this? Event fell? Entity fell. So entity fell event. And we might want to like just store this. Well, we're definitely going to need to store this. So this dot entity fell event equals entity fell event. Yep. On notify, we're going to have to notify entity fell event with that the entity fell, because like this is a subject, so we're going to have notify. Oh, okay, so it looks like physics would also take this in, right? So physics would take the entity fell event, and when it runs this, it's going to call entity fell event notify. But right now, notify is just sort of it's extending it, so it's calling it off of there. So I don't know, like I have to decide which sort of method I want to do. Do I want to do the classic object-oriented method of this, or the new method of it? I don't think my alarm rang for that it's after 8:15, but it is after 8:15, which means that it's time for me to head off. So with that, I am going to go get ready for work. Thank you everybody for stopping by and watching. This has it's been a lot of fun for me to learn through these patterns and then implement them, and I feel that I'm getting better at doing this, and hopefully my games will improve as I make them. I will push up this code, and I think I have Danny Fritz. It's been forever since I've seen you on the stream. It's awesome to see you here. You recently did an observed pattern in JavaScript in a multi-threaded environment, and it was a headache. Oh, interesting. JavaScript in multi-threaded environments. I can imagine that. It'll be interesting to see how I end up doing this in our infinite runner. Anyways, Danny, it's awesome to see you. I do have to go get ready for my stand-up though. So if you want notifications for these, you can follow here on Twitch. You can follow on Twitter. And with that, I am going to switch to the ending screen. And I will see you next time. Have a great day.